Welcome in DataOps Poland, our meetup. So our guest today is Radosław Kita, and Radosław will tell us, stage is yours.
Thank you.
Yeah, please share your screen, okay?
Yeah, okay. Can you see my screen?
Yep.
Okay, great. Thank you. So thank you for having me here. Just one organizational remark. If you have any questions, just raise your hand using Zoom and you will be able to ask it during my presentation. So I don't mind if you start asking questions during my presentation. It's totally fine. This one. Okay. Let me introduce myself. Now I'm head of data science in Ringer Access Springer Polska. I work on this market from February 2000, from the beginning of this century. And before that, I was a lecturer on the universities. I have privilege to work for Onet PR, Smart Recruiters, Alior Bank, TBN, Allegro, Beyond is quite large telecom. In fact, this is holding of telecoms based in Amsterdam. I work also from Showmax and Adform. So my experience are connected to internet or huge companies. So this is my perspective thinking of data and also my way of preparing data for analysis. Okay. And I also gave lectures on SGH and SWPS, usually on the postgraduate studies. So that's about me. I divide my presentation onto parts. First is about three main challenges in data science project. If you want to start data science, you should remember about these challenges, obstacles. They are not really sophisticated, but it is quite easy to miss this and be in trouble. So just I want to go really deeply in these obstacles. And second part is about way from PoC to productization, especially during when you work with data science project. I also want to tell you about most important reasons why data science projects fails. Some of projects that I managed in the past fails for some reasons. Now I believe that I know why it fails, so I want to give you a hand and talk about a little bit about reasons. If you talk about the three main challenges in data science projects, I think that they are people, data, and business value. These challenges are connected in that way that if we do something in one area, it will influence on another area. So they are connected sometimes in a really tricky way. I will talk about it a little bit deeper in my presentation. Next slides. So first, people. This is from my point of view, this is the most important challenge, the most important issue when we think about starting data science project. Usually, people think that way, that, okay, let's hire some data scientists from the market, let's give them some open source environment, and everything happens. Some magic happens, and we will get data science project, or we get machine learning systems. Usually it doesn't work. It doesn't work that way. Why? If you can think about Apollo project, when we think about this project, it looks like that in our heads. But in reality, it looks like that. That means that data scientist or data science team needs environment. By environment, I mean much more people, engineers, DevOps, admins, and other people around. The systems that we are built using machine learning methods, it's usually, this is heart of our system. It's a really important part of our system, but this is so much and only that much. Usually we need systems around, and usually we spend much more time on developing the systems around, much more than we spend on building this fancy data science or machine learning algorithms. And talking about open source systems, this is really important to remember that most of the systems like Hadoop, Spark, Kafka have came to us from a world of internet companies. Internet companies are a really specific one. That means that these companies are familiar with distributed systems. They have administrators who can run the system, keep the systems going, people who know how to feed the systems using data, and so on, so on. If you are a bank or a telecom, it's not your environment. Probably you are much more familiar with central systems, with one huge mainframes or something like that. So you have to rebuild our infrastructures, rebuild or build it from the ground. That means that you also have to employ, to hire people who know how to deal with these kind of systems. That could be it could be issue in case of some companies. And another things that is connected to these internet companies is that they usually hire a lot of engineers. That means that they have a lot of people that can keep the systems running and can develop the systems. So it is also important because structures of employers and such companies like, for instance, banks are a little bit different. There are not so many engineers around, so some of works are outsourced. So that also have influence on our system. If you want to start data science project using open source systems, it could be hard because we just have to hire a lot of new people to organization. So it's not so easy, it's not so cheap as we expected. There are also two other things that you should really have in mind if you think about starting data science project using open source. One, this is quite important and quite easy to miss, that you cannot be sure about comparability between elements. It can change in time. New version of one component can will work with other components or not. You cannot predict it. So you need engineers that understand this technology and can do something about that. And it's another thing that's also really easy to miss. Some companies, for instance, my company, Springer, has quite sophisticated infrastructure, and sometimes we made our work much more sophisticated using special solutions or using some systems. And sometimes we have building this data science project, we have to build some systems going around this limitation that we introduced to our work. That also means that we need more engineers, and it also means that we can expect some external support, because our systems or our environment is really sophisticated and is complicated that way that no one can deal with that. Sometimes this is quite important and also quite easy to miss thing. Of course, we do not have to stay with open source systems. We can use such systems like Teradata or SAS. But these systems are usually much more expensive. Of course, we can be sure about compatibility of each elements and so on, so on, so on. Someone is doing this stuff for us. But on the other hand, we do not pay such money for engineers, but we pay huge money for the systems, because the systems are quite expensive. So this is kind of a balance that we have to decide, balance between people and money that we spend on systems. And there's also another thing that it's important to have in mind, especially when you start a data science project from the scratch. Some companies usually have some data scientists or people with really similar to data scientists. They have these people on board. Usually they call it data analysts and so on, so on. These people are familiar with data sources. They understand business needs. They have some statistical knowledge. They understand technological infrastructure limitation. Usually, in banks, these people work in CRM divisions, or they build credit scoring models. And for some companies, it is much more easier and cheaper and quicker to learn these people some new stuff, how to build little bit more sophisticated statistical models, how to use some machine learning techniques. It's cheaper and quicker than hire new people from the market, because these new people have to learn about data sources, understand business needs, and so on, so on, so on. So not always the way of hiring new people to data science team is the best way. Especially that new people tend to something that it can be called cherry picking syndrome. They start to deal with problems or issues that are not as important from point of view. They're not the most important from the point of view of company. That's another stuff. And this is one thing. And another is that if you can imagine that you are this analyst who has been working for your company for 10 years. We did a lot of crazy stuff, preparing a lot of analysis before you understand data sources, understand business needs, so on, so on, so on. You spend years on that, and you are really one step before doing something much more sophisticated, things that you always wanted to do. And companies employing new people who doing these things beside you. So you are probably not the most happy person in the world, and cooperation between your team and team of new people, it's not so smooth as it can be expected. So finishing with people as challenging data science project. In this project, it's quite hard to keep a balance between money that you spend on people and number of people that you really need for this project. Usually, it's going that way that you need much more people that you expect. It's something that you that is good to have in head when you start to dealing with such kind of projects. Another big challenge when we talk about data science project is data. I believe that there are two aspects of issues with data. One, this is just collecting and keeping large amount of data in a way that enable us to use this data in reasonable amount of time. This is quite tricky, and I will tell more during the next slide about it. And another thing, this is keeping or ensuring consistent customer identification. This is also a thing that is really, really important in this area. Talking about collecting large amount of data and keeping large amounts of data. Usually when we build systems, computer systems, and even if we work with a huge amount of data, there is no sense to store this data for a long time. Usually, we aggregate this data, calculate reports, and delete this data. We don't need it anymore. We just calculate something like we make aggregate of weekly data, monthly data, so on, so on, so on. We don't need to keep all detailed data. But in many data science projects, we need a different approach. We have to have access to detailed data for a really long time. First, we need access to this data because we have to prepare our models. And this is reasonable. Everyone remember about that. But there's also another aspect that sometimes we have handling with complaints about our models, about results that we get. Let's imagine a situation when we build models that do something about advertisement campaigns, and something went wrong with this campaign, and our customers complain about that, and we have to sometimes we have to go really deeply in data and find reason. And that needs for us that we will keep this data much more longer when in usual situation. So it is also keeping. It also means that we have to spend much more time, much more money on building systems that are able to keep this data for so long time. This is also balance between our possibilities and money we spend on that. And sometimes we also faced some legal restrictions. In some situation, we cannot process data about individual users. Some data can be processed only for groups of users. So it's also have influence on way we will store data, way that we process our data. Next huge issue is this consistent customer identification. Usually this is not issue because usually we not combine data coming from many sources. It's usually, but when we build a science project, usually we have to merge data coming from different sources. For instance, when I work for Alior Bank, we built systems that calculate credit scoring risk, but not based on data coming from bank. We don't want to use information how people spend money. We wanted to build these models based on behavior of people in internet. So we have to merge data from banks, from bank resources, and with and data coming from internet. It was quite challenging, and we had to do that in different way that we do it usually. And we also have many limitations connected to data protection regulation. Sometimes we have data that seems to be quite useful, but we cannot use it because we can use this data for really specific reasons, not for this reason that we built our models. So sometimes they make our situation quite tricky. And another point is that different systems use different user ID. You have a bunch of possible user ID, bank account number, contract number, web browser ID, or just cookie. User ID, this is used during logging to systems, email address, telephone number, Facebook login. All of this ID has different value, business value, and it has a different lifetime frame. For instance, bank account on contract number or Facebook login, this is something that is valid for a long time. It's a little bit different about email address or telephone number. We do not expect that we will be valid for so long time. It could be valid for months or 1-2 years, but probably not longer. Different stories about web browser ID. It could be valid for minutes. It could be valid for days. Usually it's not valid for weeks or months. So during building this, the systems, on one hand, we have limitation. We have some legal restrictions that we have to follow, and on the other hand, we have to merge data with really different value and with really different lifetime frame. Sometimes building something with sense using such many different data is really challenging. We have to keep in our minds many different aspects. And business value. This is the last thing when we talk about main challenges in data science projects. It is quite important to ask question, can we make money on our models? It's quite easy to forget about it and build models that it looks nice, look really fancy, but we cannot earn any money based on these models. For instance, imagine a situation when we build anti-churn models. We want to predict who stop using our service, and we get answer that our customers usually resign from our services after 3 days during the trial period, and usually they are men between 25 and 35 years old, maybe living in large cities. How it can influence on our business model? Can we do something that give us hand to stop people from churn? It's not sometimes that kind of information doesn't give us any opportunity to deal to do something about churn. We just get a bunch of statistics that do not make any influence on our business. Another situation that is, for instance, imagine that we build some models that some recommendation models, and this model extends time spent on our web pages by 5%. How much money it is worth for us? Because we have to spend some money on building this model, on keeping this model running. That money that we earn because this increased by 5%, is it enough to cover our costs or not? And in this situation is no universal answer. Sometimes answer really depend on market when we operate it on, especially when we talk about advertisement market. We can build models that are running on, for instance, rich market like United States or German or Scandinavian market, where it's quite easy to get that on this market. When you build machine learning model, that model probably earn money in 2 months, enough money to cover your cost of working of data scientists and so on and so on. But in some market, not so rich market, this time to cover a cost of building something, it could be not measured in months, it could be measured in years. So this is really important to keep in mind that we have to earn money on this systems that we are building, and sometimes we cannot build these systems for strictly business reasons, because we will not earn enough money on that. We not make enough money on that. Okay, this is finish of first part. Are there any questions about that?
Okay, I don't see any hand raised.
Okay. So I believe that we can go further. Now I want to talk about way from PoC or proof of concept to the model factory. First, what I mean by model factory. In model factory, we can talk with, we have at least few models. This is not situation when we running 1, 2 models, and we have automated process of quality control of results of these models, and we also developed processes that start model improvement when quality of models decrease. This is quite important to have it in mind, that in the model factory, many things are going in an automatic way. And we are keep running not one model, but few of them. So in this situation, we cannot base on human. You cannot do things your way. So this is a reason that we have to build our systems in a little bit different way when usual. When we build PoC, we should remember about a few things. One is really important and also really easy to omit, that in reality we will not work with clean data sets. I saw so many PoC that have been done on well-prepared data sets, and these models work great on these clean data sets, but completely fail when we face real data. So it doesn't sound really challenging, but it's really important to remember about that. Another stuff, it also seems to be quite trivial one. We should remember about computational complexity. When you study, if you want to be a developer or engineer, data engineer, you learn about that. And but for some reasons, people forget about that. I also saw few PoC that have been done in that way, that computational complexity was N3 or something like that. It was extra complexity that make the systems completely useless. And also, usually I work in world then time really matters, because systems that usually I build have to do something between moment when a user clicked on link and user will see web page. It is a really short time. This is a period of time in milliseconds, 100 milliseconds, even less, 100 milliseconds. So it's really important to have it in mind that our systems in production will be work with huge amount of data and have to answer really quick. Another point is feature engineering. This is something relatively new. And it means that when you start with few variables, you can calculate many new variables based on this old one. You can calculate many features based on the old one features. For instance, if you have revenue from users, you can calculate weekly revenue, 2 weekly revenue, 3 weekly average for months, so on, so on, so on. You can also build many complex features based on that. For instance, revenue per user, per number of page views made by users. And some of these features are really useful during the process of training models. Some of it not. Usually it's going that way that you build few hundreds features in a really easy way, but in models you use few of them, 10, not more than 20. And this is different story to build, to develop code that make this feature engineering during process of working, preparing data to analysis, and different story to give this code from production systems. In production systems, you don't have to calculate these hundreds of variables. You just need these few variables that you use in your models. So it means that after during PoC, you start with feature engineering, build models, and after that, on the end of this process preparing PoC, you have rewrite your code and keep only these features that you need, that you really need for your models. Sometimes it means that you have rewrite all this process of preparing data or remove some methods that you use because these methods do not have any sense in this moment. They don't need this. You don't need these methods for calculating these features that you need in models. People tend to forget about it. That means that you get systems that calculate 1,000 variables for some reasons. That is time consuming, but for your model you need only 10 of them. And another stuff, this is also quite common, that data scientists sometimes use really exotic languages. Exotic from point of view of production systems. For instance, R is this kind of language. This is quite good in prototyping. But this using R, you cannot build systems with such efficiency that you can put it in production. So if you want to use R, it's great. On prototype praise, that means that you can easily check a few groups of models. But if you want to show results of your PoC, give code on the end of the PoC, this code should be written in language that is acceptable from point of view of production systems. No one is going to change really sophisticated production systems because you want to run your single model written in exotic language. And another thing is also tendency to using exotic libraries. Sometimes when you get some PoC, you are almost sure that is something. This is effect of crazy night that people spend with Google and Stack Overflow. It is quite easy to find a solution of each of your issue using Stack Overflow, but usually the solution is far away from effective one. And sometimes people find solutions using special libraries that are used only this one time, only for these solutions. And sometimes these libraries do not exist on the production systems because on the productions we're using only a little bit older version of language, or these libraries haven't been built from for operation system that is used on the production systems. So it is also important to have in mind that kind of limitation. And another point is a little bit more. It's from different side than technology. This is when we start our PoC, we have to choose criterion of success. What success mean for us? Which kind of metrics we will use for that? And there are many ways of measure success. You have a list here like accuracy, precision, recall, or F1 metrics. And you should choose it wisely. Because in some situation it is easier to get high precision, but we are not looking for precision in this moment. We are much more interested in recall, for instance. You can imagine a situation when you are building models that calculate credit scoring for customers, and this is different situation when you give credit to someone who doesn't need it, from situation when you give credit to someone who will not pay this credit because of ability of his abilities, or this person doesn't have enough money to cover this credit. So you should really honestly discuss consequences of methods that you use, criterion of success that you want to use. You should discuss it with your stakeholders and be double check if stakeholders really understand what you want to measure and how you want to measure that. Because this is quite easy to go to people and say, oh, this is something that it was calculated by artificial intelligence, and people usually say, oh, if this is calculated for artificial intelligence, it must be great. Sometimes it is, sometimes it's not. So it's a good idea to double check if people understand what you want to do, and to be sure that things that you are going to do is exactly these things that they expect, because sometimes they are really disappointed on the end of a long and costly process. And there are also another group of things that it's good to have in mind. And on one hand, I shouldn't talk about that because they seems to be a really simple one. But I also was a few times in a situation when someone forget about that. This is just keeping development standards of development, of standard of writing code. You cannot call your object like list1 or temp, something like that, you should do a unity test. For instance, I was in a situation when external company did PoC for us, and they give us called us one huge function. It was ridiculous, but they did it. So this is not easy situation when you have to talk to this company and say, oh, this is not this quality of code that we expect. You should follow some rules, so on. And if you get this kind of PoC that doesn't follow these rules or coding standards, it means that in fact you have to rewrite everything from the ground. So it's a very costly situation, and it's also a situation that is not really loved by people from your team, or data scientists or engineers, because rewriting code of other people, written by other people, it's not the most funny thing in your life. It's also not always the easiest one. And another thing, this is oversimplification when we built PoC. Also a few years ago, I was in a situation when I worked for Allegro. We were looking for a system that give us identification of objects, and usually we get systems that were great, really great, but they work really great, but only on object without any background, or just on the white background.
Radek, I see that we have one question at chat. Do you want to answer right now or later?
Okay, I can answer, but how to find this question?
Okay, I can.
I believe that I can find it, but oh yeah, more chat. Okay, yeah.
I will probably, Philip. I will unmute you so you could ask your questions.
Hi. So I would like to ask about open source softwares for data science, because I was using Jupyter notebooks. And how is this compared to real data science work team?
No, I'm not going to say that open source is not good. Usually, in most companies I work with open source. For instance, it was at the internet companies in Ringer Access, Springer. This is the way that we work with. We work with open source systems. Also, for instance, for Vion, I was involved in the process of moving all company from the paid systems to open source systems. I'm just saying that I want to say that these systems have some limitation, and you need extra people to cover this. And just you should have in your mind that you should do that. And Jupyter notebooks are really fine. We usually work with Jupyter notebook. At Raspberry, we are writing our models in Python and implemented in Python. So it's also easy to export this your code from notebook to Python code and implement it in the systems. In some company it doesn't work that way because this models should be implemented in Scala or Java, because they should be much faster than Python. And it also depends on environment, production environment that is used in this company. But I believe that Jupyter Notebook is in this moment there are some kind of standard in data science work.
Okay, thanks.
Okay, so sometimes we have tendency to oversimplification our problem, because for instance at Allegro we need something that will be able to detect object independent on background, because you cannot expect that people make picture of book on the white background or shoes on the white background. Usually these pictures look like that you have shoes and something in the background. So it's you should remember about that. And because sometimes you you make your problems more simply that is necessary. You're working on different project, different issue that you need. So it's also important to remember why we are building this the systems and what kind of data the systems will work in the reality. And another thing that we should have in mind, this is really dumb, but to forget about it, but it happened. This is scalability of our systems. This is going that way. Scalability means two things for me. One is that that our system should be ready to adapt to evolution or changes, because our traffic will be increasing month after month, hopefully. We'll get more users, more page views, so on, so on, so on. And we are not going to change architecture of our systems or components of our systems in 2 years. So when we build systems, we should remember about that the systems also be able to work in 2 years, 3 years, 4 years, 5 years time. And another thing is that also sometimes these changes can be really rapid. For instance, due to pandemic, we noticed a huge increase of our traffic volume, huge. And we have to deal with that. We cannot stop our business for a few days or few weeks and say, oh, sorry, we cannot handle with this such huge traffic. So give us some time and we build something new. And some solutions that you get from the PoC really miss this point. And flexibility. Flexibility is much more about economy than just to keep systems around. It means that we are living in quite changing world. This is especially when you work for media like newspapers or internet portals. You can lose some data sources. You can gain new data sources. It can happen, and it happens every single month. And another aspect is that if you build some technology, you build some systems, it is also good to have in mind that maybe you can use the systems not only in one place, but in other places that make this systems much more universal one. For instance, when we build models that optimize click-through ratio for mailings. Maybe we should develop it that way that we can that they will be reusable for display advertisement or the recommendation systems. Maybe not all, they don't follow the systems, but some part of the systems can be reusable. This is quite important because this has impact on the cost of our solutions. And I believe last thing is humility. This is not we are important player on this market. We are important. Data science is important player between in the game between business and IT. But we should listen carefully. People from business, we should listen carefully people from technology, because we don't want to build systems that are useless from point of view of business, and we don't want to build systems that are really hard to implement by people from technology, or they are not possible to be implemented by people from technology because it's some limitation. And it also means that sometimes we are not able to implement very fancy new modern algorithms or statistical methods. We should stay with old one. This is not it's not really ambitious plan, but this is something that we should do for reasonable reasons. That's all. Thank you very much for your attendance. And if you want any questions, please ask now, or you can send these questions by email.
Okay, so do we have any questions? Nothing on chat. I don't see any hands raised. Let's give people a couple more seconds, and maybe some thought will clarify. Okay, I believe we do not have any questions. Radek, thank you very much for your speech. I have got a great time listening to you, and thank you. I hope you will you also enjoyed that, and I hope you will get back to share your wisdom in future with us.
Thank you very much. Thank you for having me here, and thank you for your attendance.